Hello. Electric boats here on the Thames in the UK, they're very popular and they are good. But in this video, I'd like to propose an evolution, an improvement that can be made and to make them even better. The standard electric boat is fairly simple. It has a set of batteries, 24 volt maybe, or 48 volt in my case, and those are connected to an outboard motor or an electric motor to get to the propeller. Now, the sad fact is that the instant that you connect the battery to the electric motor, the voltage drops and you never get 48 volts delivered to the equipment that is rated for 48 volts. I'll show you a measurement. This is my skiff out there on the Thames, and the vertical lines are every half hour, and you can see on the left hand side the scale in blue and the blue line. The instant the electricity was connected to the electric motor, the voltage dropped from 48 volts to 46 point something, and then every half hour, which is when I measured it, the voltage fades away. The battery is being drained down, the voltage goes down, and with the red line you can see there on the right hand scale, the speed drops just steadily in line with the dropping voltage. Now, many people will probably say, you can solve this problem by having more batteries. No, you do not solve it. It's still there. It may be less, but this is the very fundamental nature of batteries, that as you drain them, they lose the voltage and you lose the speed. The alternative that I'd like to suggest is that instead of a set of batteries in the boat, you have a generator, a Stirling generator. I'll come on to that later. But this generates 48 volts in my case, and that goes through to the electric outboard, and I get 48 volts throughout the entire journey. Here's my measurements. So you can see the blue line is hovering around 48 volts, and the red line, which is the speed of the boat, is higher and also very steady. I do not get what I call trip fade. The Stirling engine generator is making 48 volts, then it goes through to the propeller and I get a steady speed. Now, generators. In boats, they've not had the happiest of, press over the years. They do make a lot of noise, or can do. They also need maintenance, and they also have an emissions issue. But have a look at this Stirling generator set. It has extremely low maintenance. This is what Stirling engines are famous for. Recently, the engine I've got, Microgen's SPC, Stirling Power Cell, one of them, there are 18,000 of them out there in situ, in installations. One of them has been reported as having run for 50,000 hours with no maintenance, unattended. It's turned itself on and off automatically, and no maintenance. And it is extremely quiet. The rating is down in the 40 decibel range. I am talking to you now in the 60 decibel range. So yes, it is an electric boat. You can hear the birds. It's just like an electric boat is quiet. And on the emissions front, I have a Honda Jazz car. Every year it has to have an emissions test. And the emissions coming from the Stirling engine generator are about 1/10 of the required level for my UK-based car. So in summary, I'd like to refer to the benefits that I see by this proposal. The boat I have got, it's out there and it works. One of the first ones that you notice is that you come back at the end of your journey at the same speed as you set out. There is no trip fade. But for me, a bigger issue is that year on year, you get the same performance. With a battery set, they do decline. You might get 8 years, but each year you have less capacity in the battery, and that means less trip range and less speed. So year on year battery decline, and without a battery set pushing it, you don't have to press you don't have to put a charger in to charge it. So thank you very much. I shall just leave you with the speed comparison between the red line here of the boat being driven by the Stirling generator and the blue line when it is being driven by a battery. Thank you very much.